Hello friends, this is part 2 of Electromagnetic Theory paper C-13 2024 6th semester Dibrugarh University. So before we solve this paper, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And this is my Insta ID OJHALAKHYAJIT123. If you want to follow me on Insta, you can follow me. Okay, and I have already given the answers to all the MCQs of question number 1. Question number 1, A, B, C, D. How many questions were there in MCQs? I have given all the answers. So today I'm going to give you the answers to question number 2, 2A, 2B, 2C, so on. Okay, so let's start. So here is the first question, 2A. I have made already video on this topic, electromagnetic potentials. So I have made videos on scalar potentials and vector potentials. So link is in the description box. I have written 2A and link is provided there. What's that video? Then you're gonna get this answer. Now let's move on to question number 2B. 2B. Determine the numerical aperture of a step index 5 of when the core and cladding refractive indexes are respectively 1.5 and 1.4. So here let me show you here. That's very simple, not so hard. So here refractive indexes are given. So n1, the refractive index of the core is 1.5 here, then n2, that is 1.4. okay, so this is question number 2B solution. Okay, question number 2B solution here. So the numerical aperture is given by root of 1.5 whole square minus, that means this is the formula. You see, formula is this: n1 square minus n2 square whole to the power half. So you're gonna apply this formula. So that is 1.5 whole square minus 1.4 whole square whole to the power half, right? So here you see a square minus b square, that is a plus b into a minus b, that is 1.5 plus 1.4 into 1.5 minus 1.4, and this whole to the power 1 by 2, or you can write square root as well if you want to write instead of 1 by 2. So then sum of these two is 2.9, then difference of these two is only 0.1, and we have whole to the power half. So if you multiply this two, then you're gonna get here, half means root over here, so it is 0.29, and this is approximately equal to 0.54. okay, if you find the square root of 0.29, then you're gonna get approximately equal to 0.54. okay, so take the screenshot, or you can pause the video and you can write it. So now let me erase this. So okay, now let me answer to question number 2C. Classify the optically active substances and with examples. So let me write the answer. So here is the answer to question number 2C. okay, take the screenshot. Now next question is 2D. Obtain an expression for the electromagnetic energy density in free space. So let me give you the answer. Question number 2C, sorry, not 2C, 2D, that's supposed to be 2D answer. We know that magnetic energy density is U, let me write B to represent magnetic, 1 by 2 1 by mu naught B square, right? And electric energy density is given by, let me write this here, electric energy density is given by UE, let me use the black ink here, UE is equal to 1 by 2 epsilon naught E square. Okay, so if we add these two, then we're gonna get electromagnetic energy density. Electromagnetic energy density in free space is U is equal to UB plus UE. So if we add these two terms, UB, instead of UB we're gonna write this, and UE is this, right? So this is here you see, so epsilon naught is the permittivity of free space, and mu naught is the permeability of free space. So that's why this must be the electromagnetic energy density in free space. So hope you know the meaning of the terms used here. So this epsilon naught is permittivity of free space, and mu naught permeability of free space. And this E for E is electric field, and B is the magnetic field here, right? So hope you have understood this. So this is the answer to question number 2D. Now let me give you the answer to question number 2E. What is optic axis? Give an example of crystal having two optic axes. So let me write the answer here. Question number 2E. Okay, question number 2E. 2E answer. First let me write what is optic axis. So here is the definition. This is the definition of optic axis, and here you see, and you need to write the example of crystal having two optic axes. So that is here I have given mica. Okay, suppose it is not suppose you are asked to write crystal having one optic axis. Okay, it is not asked in this question. Suppose if it is asked, suppose crystal having one optic axis, so that's going to be calcite. Okay, remember this one also, it may be asked. Okay, so now let's move on to next question. So 2F, find the reflection and transmission coefficient for normal incidence in a glass air interference given refractive index of the glass is 1.5. So how to find it? So now you see refractive the reflection and transmission coefficient. Reflection coefficient R is given by n2 minus n1 whole square by n2 plus n1 whole square. So here it is glass air interface. Refractive index of glass is 1.5, that is given, and that of air, let me write this one here. We know that refractive index of glass, let me write here n1, that is 1.5. This is for glass, right? This is for glass. And for air, n2 is equal to, for air it is 1, right? It is not given in the question, but when you have air, then take it as 1. So then 1.5 minus 1 by 1.5 plus 1. Okay, so here we have to square it, then 2.5 whole square by, here first one is subtraction, so it's gonna be 0.5 square, 0.5 square by 2.5 square, right? So that means here you can write 1 by 1 by 5 square, or you can write 0.2 square, that's going to be 0.04, right? 0.04. Now let me write find the transmission coefficient. Okay, transmission coefficient. So how to find it? This is the reflection coefficient, and let me write the transmission coefficient formula. That is given by T is equal to 4n1 n2 divided by n2 plus n1 whole square. So then 4 into n1 is 1, n2 is 1.5, sorry, yes, 1.5. Then n2 is 1.5 plus n1, sorry, here we had taken n1 as n2 as 1, right? So let me replace it properly. n1 is 1.5, n2 is 1, then by n2 is here 1, then n1 is 1.5. okay, that's it. So now what we're gonna get, if you calculate this, then what you will get, 4 into 1.5, 4 into 1.5, right? That's gonna be 6 into 1, 6 again. So we can make it 6 here, and 1 plus 1.5, that's gonna be 2.5. So 6 by 2.5, right? So if it is 6 by 2.5, then if you remove the decimal, then what you're gonna get, you're gonna get 60 by 25. okay, so now 5 5 is 25, 5 12 is 60, and if you divide 12 by 5, then 5 2 is 10 point here, 5 4 is 10. That's gonna be 2.4. This is the answer to question number 2F, right? That's how we can solve it. So hope you have understood this. So thank you for watching. See you in the next video. Remaining questions will be solved in the next video. Bye bye.